All right, today we are solving log equations. So the steps, there's kind of three of them. We're going to start over here by listing what they are. First thing is you need to use the log properties to get a single log on either side of the equation. So use log properties to get a single log on each side of the equation. So when I say use log properties, the idea that we know how to condense logs. So there's three things that you knew from the other day. If you have two logs that are added together, so log of A plus log of B, that's the same as having the log of A times B. If we have two logs separated by subtraction, that's the same as having a single log where you're dividing on the inside, right? And then the last thing, if we have a number in front of a log, so like A times the log of B, we're allowed to take that coefficient and bring it up and make it the exponent. So that's the same as having log of B raised to the A power. So there's a quick review of those three properties that we're going to use throughout the notes for today. Once you get a single log on either side, step two is you're going to get rid of the log by exponentiating. So you're going to exponentiate. There we go. To undo or essentially eliminate the log. So we're going to take it from a log equation to just a basic old equation by getting rid of the log. And then the last step, step three, whatever equation you have left, you're going to solve that. It's basically what we're looking at. So you're going to solve the resulting equation. One thing to keep in mind, you do need to reject any answers not in the domain. And from the notes from yesterday, what you want to remember is you cannot take the log of anything negative. So maybe put that little note here. So you cannot take the log of negative numbers. And the base of a log also can't be negative. Right? So no negatives, get rid of them. So first example, we'll start nice and simple, work our way up. So log base 3 of 2 plus log base 3 of 7 equals log base 3 of x. So it's not super important what the base is, but it is important that they all have the same base. So the fact that they're all log base 3 means that I can, actually combine them. If this was log base 3 here and log base 2 here, I wouldn't be able to combine them. Different bases, they're not the same thing. Can't just magically smush them together, all right? So because they are the same, they're split by addition. We bring them back together using multiplication. So that's my key here. When I see that addition here, means I can make this log base 3 and then of, take what the first log is of, take the second one, and we're multiplying those pieces together. So 2 times 7 there. And then just keep the right-hand side. Now you have a single log on either side. So that's step 1. Step 2, exponentiate to get rid of the log. So here, the base is 3. So I'm going to do 3 and raise it to the left-hand side. Do 3, raise it to the right-hand side. That effectively cancels the log on both sides. And then what I'm left with is just 2 times 7, which is really 14, and then equals the x from over here. Ta-da! Done. As for rejecting any answers, just think, if I put 14 up here, that's a positive number. It's going to be perfectly fine. And then can I check it on the calculator? Of course you could. You could do log base 3 of 2, add it to log base 3 of 7, and see what decimal you get. Over here, if you do log base 3 of 14, you should get the exact same decimal. All right, next one. For number 2, I'm going to give you natural log of 18 minus natural log of x equals natural log of 6. So again, not really that important that it's natural log, but it is important that they're all the same across the whole equation. So what I want you thinking this time, all right, you have a subtraction sign splitting those two logs. So according to the rules, we're going to bring it back together and make it division. So I'm going to rewrite this as the natural log and then of, make sure you're going from left to right. So 18 and then divided by x. So inside of here, we'll go the 18 over x. And then we set that equal to natural log of 6. If you guys can remember, all natural log is the same as log base e. Right? So it's just a little reminder, which the reason that is helpful is when we go to get rid of the natural log, you have to exponentiate using the base. So e is the base that we have. So I'm going to do e and raise it to the left side, e, raise it to the right-hand side. All that matters is, see you later, there goes the natural logs. And so I get 18 over x equals plain old 6. There's a lot of ways to finish this one out. To me, when I see one side as a fraction, I like to make the other side a fraction by just throwing it over 1, and then I can cross multiply and finish. So when you cross multiply, you get 6x equals 18. It's really quick to see that, hey, x is equal to 3. And then same thing. That's positive. It's not going to be a problem. And then just to show you what I mean by checking on the calculator, because you have an ln button, this is really fast to do. I'm going to zoom in just a smidge here. So if I, whoops, other way, if I type in natural log, let me darken this up a little bit. If I do natural log of 18 and then close it up, minus natural log of, we just figured out 3, and then that comes out to about 1.79. Is that the same as the natural log of 6? Look at us, we're geniuses. All right, we've got log of x equals 3 times the log of 4. All right, so if you haven't figured it out yet, the first one was addition, so we go to multiplication. The second one was subtraction, so we used our division. The third one is the last case you have to think about. It's the idea that when you have a number sitting in front of a log, I can take that number and bring it up and make it the exponent. So on the left-hand side, I will just keep the log of x. On the right-hand side, this becomes log of 4 raised to the third power. From here, you got to undo the logs. So when I see log with no base, that is log base 10. That is common log. So we're going to exponentiate using a base of 10. So it's 10 raised to the left side, 10 raise it to the right side. Cancel that out, I get x. Cancel this out, I just get 4 cubed, and 4 cubed is 64. So my answer is 64 here. The next one I'm going to give you log base 6 of x plus 1, and then plus log base 6 of x minus 4 equals 1. Read it just like the last question, or excuse me, the first question, in that we're adding 2 logs. So if my first goal is to get a single log, okay, then on the left-hand side here, I can make this log base 6, and then inside, what I'm going to do is multiply together the x plus 1 and the x minus 4. That's the first thing. So x plus 1 and then x minus 4. On the right-hand side, if it doesn't have a log, that's actually okay. Just bring it down. We'll talk about what we're going to do with that in a moment. I need to multiply this out, which means we're either doing a little box method or we're doing a little FOIL. So you choose. You can do the work off to the side. So maybe over here, and go a little x plus 1, a little x minus 4. And so that's going to give me x squared minus 3x minus 4. So that's what I'm going to replace this inside part with. So let me clean this thing up first. So I'm going to get log base 6 of what we just said, x squared minus 3x minus 4. Step 2, exponentiate to get rid of the log. So since it's a base of 6, we're going to use 6 and raise it to the left side. We're going to do 6, raise it to the right-hand side. When we do that to the log, it just cancels, and I'm left with x squared minus 3x minus 4. When you do it to the right-hand side, make sure you understand how this reads. This just reads as 6 raised to the first power. So 6 to the first power, well, that's just 6. So if there isn't a log there to be canceled, you'll just actually raise that to whatever power is over there. From here, now you've got a quadratic equation to solve. So for quadratics, we always get them equal to 0 and then factor. So subtract the 6 on over. So you get x squared minus 3x minus 10 equals 0. And then it's a little add multiply guy. So think to yourself right now, what adds to 3 multiplies to 10? Hopefully you're already racing me to it. It would be minus 5. And then a little plus 2. And then when we solve, usually we don't show this step, but I like to be thorough. We get x equals 5. We get x equals negative 2. When you get to a question like this, please make sure that it makes sense back in the original, because sometimes our inclination is just to immediately reject the negative. I want you to check first. So what I mean by that, if I take 5 and I think about plugging that back into the original, this would have been log base 6 of 5 plus 1. So that's fine. That's a positive number. And then log base 6 of 5 minus 4. It's pretty close, but it's going to work because this will be a 1. This will be a 6. We should be good to go. And of course, you can actually check and make sure that the numbers do check perfectly. In terms of the second part, if I do log base 6 and then of negative 2 plus 1, yeah, right there you can see, hey, that's negative 1. That's not going to work. If you type into your calculator log base 6 of negative 1, it's going to give you that error message. So right there, we can reject that and accept that just x equals 5 is our answer. For number 5, I'm going to give you is log base 2 of x plus 5, and then minus log base 2 of x minus 2 equals 3. So they're split by subtraction, which means when we bring it back together as a single log, we're going with division. So make sure, left to right, it's this guy divided by this guy. So x plus 5 and then over x minus 2. This one is just like the last one. There is no log on the other side, but that's fine because now we know how to handle that. So my next step is to get rid of the log, because right here, it's a base of 2. That's what we exponentiate with. So we're going to do 2, raise it to the left-hand side, do 2, raise it to the right-hand side. Please, 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 as a little side note, do not write this like that. That does not, like that. That doesn't make any sense. It's the same way, like if I said take the square root of 16, you wouldn't put like the square root after it. Like that doesn't make any sense. Don't do that. So when you're writing this in here, make sure it reads correctly from left to right. 2 raised to the log, 2 raised to the third power. That's my little soapbox moment. All right, this cancels out. We get x plus 5 over x minus 2. Here, this is 2 cubed. You guys know what 2 cubed is. 2 cubed is just 8. So I'm going to substitute in an 8 there. So x plus 5 over x minus 2 is equal to 8. Just like last time. I'm going to throw it over 1 and cross multiply because it just makes more sense to me. So when I cross multiply this, I get x plus 5. Please make sure that the 8 gets distributed through the x minus 2. So 8x minus 16. And then this is just a basic old linear equation, which means just get your x's together. Move your constants to the other side. So we get 21 equals 7x. And x comes out as 3. I still want you to make sure that that answer is going to work. It doesn't have to be an extensive check, but I want you to go back up top and make sure if you put a 3 in the original that we're going to be okay. So I'm going to slide back up. If I put a 3 right here, 3 plus 5, that would be 8. I'm good. If I put a 3 here, 3 minus 2, it's going to be 1. I'm going to be good. All right. But if either of those doesn't work, even if this one works, but this one doesn't, the second one part doesn't work, reject the answer. All right. All right. Last question. I'm going to give you log of x. Oops, slide this up a little. And then plus log of x equals 2.